Alrighty, so this is section, can you see that, 11-1 on inverse variations. So we have looked at direct variations. Direct variation is one that has a constant slope. That's a linear relationship. A direct relationship has a constant slope that goes through the origin. Well, what about an inverse relationship? An inverse relationship, as we'll see, is a curve. Let's talk about direct relationships first, because that's one you're familiar with. So when you divide, basically this is rise over run, right? So when you divide the y value divided by the x value, you get a constant, k for constant. They use k for this constant of variation or constant of proportionality. That's the term. This is a direct relationship, a direct variation. So as y increases, x increases proportionately. Okay, so you can write it as y over x equals a constant, or you can write it as y equals the constant times x. Think y equals mx plus b, but b is 0. All right, so y equals a constant number times x. For example, if I had data points for x equal to 1, y equal to 3, x equal to 2, y equal to 6, x equal to 3, y equal to 9. If I divide y over x for each one, 3 over 1 obviously equals 3, 6 over 2 equals 3, 9 over 3 equals 3. They all equal 3, so k, the direct, the constant for the proportionality is 3. Okay. Whereas over here, for an inverse relationship, it's not y divided by x, y or x times y equals a constant. X times y equals a constant. X times y equals a constant. They're called the constant of variation or constant of proportionality, the constant of variation for an inverse relationship. We actually use this concept in a variety of places, especially I use it in physics. So for example, if I have x equal to 1, y equal to 16, x equal to 2, y equal to 8, x equal to 4, y equal to 4, notice that as x goes up, y goes down. So as one goes up, the other one goes down. But if I multiply x times y, I get the same number. So 1 times 16 is 16. 2 times 8 is obviously 16. 4 times 4 is 16. That's not the case here, right? Again, this is a direct relationship where 1 times 3 equals 3. 2 times 6 equals 12. When you multiply, they don't equal each other. That's definitely not inverse. So that's why I wrote this here. So in this case, x times y most definitely does not equal a constant. Okay, so if you had, I'm just going to give you some examples here. Sorry, I don't have much space, so I'm going to have to erase these. Of course, you can always replay these. I am on, by the way, I'm on page 676, and I'm just taking the examples from the book. So x equals 2y, what kind of relationship is that? Well, x times y equaling a constant, that's an inverse relationship. This one, if I solve for y, so this is example 1, I can do 2y equals x, just switch it around. Divide by 2, I get y equals 1/2 x. Or y divided by x equals 1/2. So k is 1/2. But that is a direct relationship. So this is not inverse, it's direct. Okay, again, it's notice when these are in the numerator on opposite sides of the equal sign, that's going to be a direct relationship. I'll say that again. When these are in the numerator on opposite sides of the equal sign, that's going to be direct. When they're in the numerator and they're both on the same side of the equal sign, that's going to be inverse. Just a little clue. So if we look at this next example, 2xy equals 10. And so x times y must equal 5. I just divided by 2 to the other side. Divided each side by 2, I should say. So this is an inverse relationship where the constant of proportionality is 5. All right. So Let's look at example 2 on page 677. It says that assume y varies inversely with x. So we're going to make the assumption that y varies inversely with x. And if y equals 18 when x equals 2. So y equals 18 when x equals 2. That is our assumption. So we know that if it's an inverse relationship, x times y equals k. So 2 times 18 is equal to k. So k must be equal to what? 36. Wait, Chihuahua. 36. The reason why that's important is now we can find other data points. So if I want to know, I can write that as that, like that, if I want to, or I could write it as if xy equals 36, y equals 36 all over x. All right. An inverse relationship is one where y varies with the reciprocal of x. A direct relationship, y varies directly with x. Let me repeat that. An inverse relationship is one where y varies with the reciprocal of x. X is when it's on the other side of the equal sign, x is in the denominator. That is an inverse relationship. One more time. When I solve for y, x comes over to the other side. I divide it through by x, x ends up in the denominator. That's always an inverse relationship, as opposed to a direct relationship where y would vary directly with x, and x would be in the numerator. Okay, that would be a direct relationship. So if I wanted to figure out what's the value of, based on this data right here, what's the value of y when x equals 4, all right? So find y when x is equal to 4. Now that we have an equation, that's fairly simple. So y would equal 36 all over 4, which would equal, 9? I could find y when x equals 6. So y equals 36 divided by 6, so y equals 6 when x equals 6. Now that we have the value of k, we can find any value for that, for this function right here, okay? All right. Next example, let's say what they call the product rule for an inverse relationship. The product rule for inverse variations. Is simply that you know that x times y equals a constant. That means that x times y for one data point in the function must equal x times y for another data point in the function, because they all equal the same value. That's what in the very first example, 1 times 16 equals 2 times 8 equals 4 times 4. They all equal, in that case, what, 16. So in this example, they have they say, if this is example 3, if y equals 3 when x equals 12, then find the value of, find x when y equals 4. Okay. Find x when y equals 4. Okay. So when x is 12, y is 3. Find x when y is equal to 4. Just plug in the numbers and solve. Oh, what's 3? 12 times 3 is 36. divide 3 by 4, and x is going to be equal to 9, right? Okay, I think I have time for one more example here. I'm going to actually go ahead and stop this and put this on another video.